Hello, today we're going to talk about atoms. So the idea of atoms started way back in the idea of the 5th century BC. And the word atom comes from Greek, a word atomos, which means indivisible, meaning that you can't break it into smaller pieces. So the idea of an atom is that it is the smallest bit of an element that can't be broken into smaller pieces without changing the properties of that element. So in 1808, a man named John Dalton put together something called the atomic theory. And the atomic theory had three parts. The first was that each element is made of atoms. The second part is that all atoms of a given element have the same mass and properties that make it different from atoms of different elements. So we're going to say that atoms of a given element have the same properties that make them different from other elements. And the third part of the atomic theory is that atoms combine in simple whole number ratios to form compounds. So atoms combine in simple whole number ratios to make compounds. Okay, so that gives us just a beginning to work with. So when we talk of atoms, they're composed of three main parts that we're going to talk about in this class. So let me draw you a picture of an atom to give you an idea here. So we're going to call this the atom. Inside the middle of the atom is our nucleus. So we call that the nucleus. And inside the nucleus we have protons, which I'll represent with a P, and neutrons, which I'll represent with an N. So P is for protons, N is for neutrons. Now, the number of protons and neutrons will depend on what element that you're looking at. Outside of the atom, we have orbitals, and these orbitals are where you find electrons. And I often refer to electrons as E negative. Okay, so sometimes you'll see me draw them as circles, other times I'll represent them as E minus. So as you can see, the protons and the neutrons are found in the nucleus, and the electrons occur in orbitals outside of the nucleus. So if we look at what each of these particles weigh, so let's first look at protons. So protons, if we were to write the mass of protons in scientific notation, that's how we would write it. 1.6 times 10 to the negative 27th kilograms. That's a really small number, right? Each of these means we move the decimal point one space to the left. So imagine moving the decimal point 27 spaces to the left and adding zeros, that's a really small number. The mass of a neutron is similarly quite small. So small that we really can't see the difference in the masses. A mass of an electron, though, is quite small compared to the others. So mass of an electron, and this is not proper scientific notation, but just to give you an idea. So where these are 1.6 times 10 to the negative 23rd, this one has some more zeros added, right? So this is a very small mass compared to that of protons or neutrons. So typically, instead of representing masses like this, we express the mass in AMUs. And AMUs mean atomic mass units. And AMUs are just easier ways to express it. So for protons, we would say protons have an atomic mass of 1, neutrons 1, because they're just about the same, and electrons have 0. Okay. So when we're talking about protons, neutrons, and electrons, we also want to talk about charge. So I'm going to change my chart a little here. Here's my protons, my neutrons, my electrons. And now I'm going to add charge to the other side. So the charge of a proton is positive. The charge of a neutron is neutral. So look at this, neutron, neutral, right? Electrons are negative. So the idea here is that when you have your atom, and inside your atom you have your nucleus with your proton, let's say we have 2 protons in the middle, and out here we have 2 electrons. What that means is that these are attracted to each other and they cancel the charge of each other because these electrons are negative, these are positive, and the charge is canceled to make it neutral. What we also have happening here is that these are attracting each other, right? If you think about magnets, if you have a positive magnet and a negative magnet, they attract to each other, right? But if you have charges that are the same with a magnet, they repel each other. So you can think about that when you think about the atom being held together. So now we're going to talk about how these differ between different atoms. And so we're going to start by looking at, I'm going to draw you an enlarged version of one of the boxes on the periodic table. We're going to start with hydrogen, okay? And on different periodic tables, this bottom number might be slightly different. As you get into higher levels of science, you will probably talk about that. So we define the atom by the number of protons, okay? So the number of protons is important, and this here, top number, tells us the number of protons. We refer to this as Z, which equals the atomic number. It tells us how many protons are in the atom. Right here in the middle, this is our atomic symbol. Okay, that atomic symbol gives you the abbreviation for the element. So this one's for hydrogen, and on a lot of periodic tables, they'll also put the word hydrogen in there. And you'll notice that some of the elements have strange names. A lot of elements are named after people, countries. Others that don't seem to match their symbol, such as sodium, which has the symbol of Na, are based on Latin names, so they're not always based on English. Okay. So using this information, Oh, I forgot to tell you about this bottom number. This bottom number is called the atomic mass number. Okay, so this atomic mass number, what it is it's the sum of the protons plus the neutrons in the atom. And we say the protons plus the neutrons because the electrons don't really have a lot of weight. Okay, so this is the protons plus the neutrons. So for our purposes right now, we're going to practice we're going to learn how to figure out how many protons, neutrons, and electrons are in an atom based on this. Okay, so I'm going to erase a little bit of this. So to tell how many protons, you just look at the atomic number. So this top number tells us the number of protons. Well, since atoms have a neutral charge, this is also equal to the number of electrons. So in an atom, the protons and electrons are equal to each other, and they're represented by this top number. Now, to find the number of neutrons, what you need to do is you need to round the atomic number. So in hydrogen, this 1.0079 rounds to 1, right? So since the atomic number is the protons plus the neutrons, if we want to know how many electrons there are, we would just say 1 minus 1. So you subtract the atomic mass, or I'm sorry, the atomic mass minus the atomic number. And you'll get your number of neutrons. So here, 1 minus 1 gives us 0. So in this atom of hydrogen, there are 0 neutrons. So I'm going to go now and go ahead and draw my hydrogen, now that I know how many protons, neutrons, and electrons it has. So if I'm drawing my hydrogen, I'm going to start by putting my nucleus in. And I know there's 1 proton in the nucleus because the atomic number, again, that's the number on the top here, is 1. Okay, so I have 1 proton. I know that there are no neutrons because when I say 1 minus 1, I get 0. So there are no neutrons. I know that there is 1 electron, and that 1 electron is going to go in the orbitals outside the nucleus. So I'm going to put my 1 electron right here. So how this works with electrons is that each orbital can hold a different number of electrons. For our purpose, we're going to say the first orbital can hold 2 electrons, and the next orbital can hold 8. And going outward from there, each next orbital would also have 8 electrons. Okay, so I fill the inside one first, then I move to the next outer one, and I keep moving out until I have used up all my electrons. So right now we're looking at a hydrogen atom. Okay, we're going to try another one, and then I'll give you some to practice. Okay, so let's look at calcium. So calcium is Ca, and if we draw out the box, on the top is the number 20. Underneath is the number 40.078 and the symbol calcium. So first let's decide how many protons, neutrons, and electrons calcium has. So here my atomic number gives me the number of protons and also the number of electrons. The number of neutrons I get by saying 40 minus 20. And 40 minus 20 gives me 20. So I also have 20 neutrons in this atom. So I'm going to go draw it now. And rather than put 20 P's and 20 N's in here, I'm just going to put P20, N20 to represent that there are 20. Then I'm going to draw my orbitals. And I'm going to be putting 20 electrons in here, so I'm going to need several orbitals out here. The first orbital, if you remember, holds 2, so I'm going to put 2 electrons here. The next orbital can hold 8, so I'm going to put 8 electrons here. You'll notice I usually do electrons in pairs. At this level, I'm not going to get too strict about how you do it. So far I have 2 plus 8, which is 10, so I need 10 more. So I'll put another 8 in the third ring. Okay, I still have 2 more left, so I'm going to draw those last 2 in this outer ring that I just created. Okay, so now if I count them, I should have 20 electrons. So that would be my neutral atom of calcium. You can go ahead and try this with some on your own to get a feel for it. You'll also be working on some in class.